Sometimes in industries, alarms are required. For example, a pressure vessel is there. If the pressure exceeds its strength of the vessel means it may blast. To avoid that, the pressure exceeds, the operator needs an alarm. That is called alarm. For that alarm, we have to manage that. How to manage that alarm, that we will see today. Suppose a red lamp, generally a red lamp will be there. The red lamp will glow if the pressure exceeds the safer value, exceeds the safer value. So there will be a sensor that will sense whether the pressure exceeds safer value or not. So that sensor senses that pressure value. Based on that, it will turn on a relay. This is conventional method. This is the conventional method. This is the relay, and contactor is there. In that, a lamp is connected. Alarm lamp is connected. Another end is connected to neutral. This end is connected to phase. The signal, say 1 means plus 5 volt is available, and this is grounded. The pressure signal exceeds, the sensor will give plus 5 volt. That's why this relay will be energized and it will close this contact so that this lamp will glow. Whenever the pressure falls below the safer value, then this lamp will be turned on. This is conventional. The same can be done by using PLC. For that, what is available? A plus 5 volt is available from the sensor. Logic 1 is available whenever the pressure exceeds safer value. So that signal is to be used to operate the PLC. So the PLC in the input module, X0 will receive a signal logic 1 when the pressure exceeds the safer value. Logic 1, if pressure exceeds safer value. This logic 1 can be used to operate the lamp. This is PLC. In the output module, at Y0, a lamp is connected. This is neutral. This is Y0. That is Y0. This is Y0. Logic based on that, this is 230 volt. Let us say single phase. This is the connection diagram. The programming is whenever the pressure exceeds safer value, the lamp has to blink, because if the lamp is continuously glow, no one will get that attention. To get attention, the lamp has to blink. For that, we have to generate a square wave. For that, every second it will blink. Every second or every 5 seconds it will blink like that. We have to write the program. For blinking, we have to generate the square wave. For that, we'll use a timer. T0 for 1 second. Timer T0 for 1 second. That is used. The input signal is from the second timer. The second timer, this is turned on by T0. Another timer, that is, this is also timer T1. This timer is T1. This is also for 1 second. This is normally closed. This is normally open. Let us assume that initially both are off. Yes, both are off. It means T1, here the T1 is connected. The output of this timer is connected here. T1 is logic 1 because normally closed. Because both timers are off. Initially both timers are off, therefore T1 is 1. Therefore this timer started. This is This is on delay timer. On delay timer means it will on after 1 second. It will on after 1 second. So after 1 second, this will turn on. Which one? This T0 will turn on. That means this becomes logic 1. This becomes logic 1. Therefore, it will start this. When this will turn on? After 1 second. After 1 second, this becomes 0. After 1 second, this becomes 0. That's why till then, this timer turned on. Till 1 second, it will be on. After 1 second, because the T1 becomes 1 means T1 bar becomes 0. That's why it will be turned off. Immediately, it will be turned off. Turned off. But this turned off means T0 also becomes 0. That's why T1 immediately turned off. Immediately T1 also turned off. So again it becomes 1. Again it becomes 1. The fraction of second. Momentarily it becomes 1. Which one? T1. This is, this is T1. This is T0. T0 is 1 second it was on. Momentarily it becomes 1. That time T0 becomes 0. Again, the signal becomes 1. That's why after 1 second, this will again on. After 1 second, because on delay timer. Now this becomes 1. After 1 second, this becomes 1. Again, T1 will become 1 after 1 second. After 1 second. Till then, this T0 will be 1. Therefore, T0 will be a square wave of 1 second duration. T0 will be a square wave of 1 second duration. This T1 will be like this. A pulse will come every 2 seconds. Every 2 seconds, T1 will generate a pulse. That's all. Turn on, immediately it turns off. Turn on, immediately it turns off. Therefore, this T0 can be used to blink the lamp. So the T0 can be used to turn on the lamp. Another signal is required. If pressure exceeds, the lamp has to glow. When the pressure exceeds, X0 will be 1. Therefore, X0 we would put here. If X0 is 1, the lamp has to be turned on. And it should blink. That's why you put T0 also in series with that. T0 also in series with that. Then that Y0 is, the lamp is connected at Y0. So what will happen? Whenever X0 comes, whenever X0, that is pressure exceeds the safer value, X0 will be 1. X0 will be 1. X0 equal to 1. T0 is a pulse signal. Every 1 second, 1 second square wave. That's why the lamp will glow 1 second, then turn off 1 second. Turn on 1 second, turn off 1 second. Like that it will blink. So that the operator will get attention that some variable exceeds its limit. But there must be a difference between operator notice the deviation. Immediately he cannot do anything. He has to do something to bring the values within safe limit. For that he has to do something. But there is a difference between whether the operator notice the change or not. For that some difference is there. For that there will be a signal called acknowledge signal will be there. So here one more button is there. That button is called acknowledge, AC, acknowledge. That is X1. So here another signal is available. Another push button is available. That push button is called acknowledge. That is connected to X1. Here plus 5 volt is given here. So if you press that, that one will come. It means operator acknowledge. So that X1 is coming here. That X1 is used to acknowledge. That is M0, memory variable M0. So here, if you put a ceiling contact, M0, this will be continuously 1. It means it is acknowledged. When we have to acknowledge, if the signal comes, then only. If the pressure exceeds, then only we have to acknowledge. That's why that also in series. That X0 also in series. If signal comes, he will acknowledge. Therefore, M0 becomes 1. If the operator, I know the pressure exceeds like that. He pressed that acknowledge button. So the blinking must be stopped, but it should glow. Why? Pressure is still exceeded. That's why if you put that M naught across T naught, if you put M naught across T naught, what will happen? T naught is blinking. M naught is not blinking. So it continuously glows. If the lamp continuously glowing means the operator acknowledged that the pressure exceeds its limit. If it is continuously blinking means operator not yet acknowledged. Suppose the pressure came within that limit, X naught will be 0. X naught 0 means what will happen? You see, X naught 0 means Y naught becomes 0 because X naught is in series. Y naught becomes 0. Here also X naught is in series. Acknowledge also gone. Acknowledge also gone, and blinking also, lamp also turned off. Lamp also turned off. That's all. This is called alarm management. That we will check by using simulation. Normally open T naught. Again timer. This is T1. It is 0.1 seconds. That's why we are giving 10. Okay. Square wave is generated in T naught. Now, if pressure exceeds the safer value, X naught will be 1. Therefore, we have to use X naught here. X naught is used, and T naught also used. We are going to use T naught for blinking. First, let us put T naught, then X naught, then X naught. X naught is signal. Now we have to connect the lamp at Y naught. That's all. Now we have to acknowledge, that is M naught. Sealing contact is required, that is M naught. Across T naught. Then we have to acknowledge. For that, we are going to use X1 for acknowledgement. X1. X1 is used to acknowledge. That is M naught. M naught. M naught is generated, but it is a push button. X1 is a push button. That's why we need a sealing contact to keep that value. So we have to put a sealing contact for M naught. That's all. Now we have to save that. Compile it. Run mode. No signal. But T0 is blinking. T0 is blinking. Always it blink. But X0 is not coming. That's why Y0 is not yet turned on. The lamp not yet turned on, because lamp is alarm lamp is connected at Y0. So for that X0 is required. So we have to set the X0. If you set the X0, Y0 is blinking. The lamp is blinking. If you acknowledge, it continuously glow. For that, we have to set that X1. I pressed and I have to remove that because it is a push button. If now Y0 is continuously glowing. But operator does something, the pressure, or automatically the pressure falls below the safer value. That's why the signal goes off. Y0 also goes off. But the M0 is in on. What is the bug? Bug is we have to put the X0 in series with M0. That is the bug that will do. So we have to turn off this. Here we have to put one X0. Otherwise, M0 is continuously on. Next alarm signal, it will come as acknowledged. To avoid that, we have to put X0 in series with that. Yes, we included. Now save, compile. Simulate online. Run. T0 is blinking. Now let us set X0. Y0 is blinking. Let us acknowledge by setting X1 and set. It is a push button. That's why immediately we are setting off. So it is continuously glowing. Now let us assume that the pros variable came within that limit. That's why we have to put set off. Only T0 is blinking. Only T0 is blinking. It's working fine. If X0 comes, again it will blink. The lamp is blinking. Acknowledge. Blinking is stopped. It is push button. That's why we are immediately set off. Let us assume that X0 came within that. X0 is not coming because the pros variable came within that limit. Set off. It is turned off. It's working fine.